Hi. So this next part of the naming system includes the transition metals. So look at our periodic table. Now, I often have folded the periodic table to take out the transition metals. And you've seen it look, let me get this nice and even. You've seen it look like this, okay? Now, the ones that I fold out are in the middle. So those are groups 3 through 12 in the traditional number system, okay? So Scandinavian, number 21. So let's look at period 4. Now remember, periods are rows, so they run horizontal. So let's everybody look. So we're going to be looking across this way. So we're going to look at numbers 21 through 30. Okay, so let's look at this here. So on our periodic table, okay, we have transition metals, which sit in here. Now, we do not have, we have the +1, the +2, +3, +4, -4, -3, -2, -1 above the groups that are on our main group of elements. And that includes these over here as well. They're also called the representative elements, okay? So these here, we don't have any plus or minus number over them. Now, because they are to the left of the staircase, these are all going to be cations. They're metals, okay? So they're going to give up electrons. Now, they're interesting because they're very fluid with their electrons. And sometimes they give up 1 electron, sometimes they give up 2 electrons, sometimes they give up 4 electrons, sometimes they give up 3 electrons. Now, say we're in the 4th energy level right here. So look at the ones in the 4th energy level here. So we have potassium and calcium right here. And then we have a few, let me just look at the 4th period down here where it's a little bit cleaner. So we have potassium and calcium right here. And then we have some transition metals here. Okay, let me just get those written down. Okay, so this is a group 1. This has a +1. This has a +2. Okay, now these here, these 2 electrons right here in the 4th energy level are actually the valence electrons for all of these here. Now, we don't do electron configuration in this level of a course, but trust me when I tell you that all of these elements right here have 2 valence electrons. Okay, electrons in the outermost shell. For all of these in the 4th energy level, they have 2 valence electrons in the 4th energy level, okay? But they don't always give up all of those, or they don't use all of those in bonding, I should say. Because remember, giving up the electron just means that these elements allow the non-metal they're pairing with to hold that electron closer to its nucleus, okay? So sometimes it's just 1 that it bonds with, sometimes it's 2. Now, the 3rd and the 4th come in is that they're using more than just their valence electrons to bond with, okay? So we have energy levels. So here's a nucleus. We have 1 energy level, another, another, another. This is the valence shell. So it may use 1 of these. It may use 2 of these. It may use 1 from here. It may use 2 from here. This is where it would have 4 in bonding if it was going to do this. So how do you know? Well, fortunately, there is a Roman numeral in the name. So take, for instance, titanium 4 oxide. So I require in my class a Roman numeral with every transition metal. Now, at higher level courses, sometimes with silver, for instance, because silver most often bonds with one electron, um, it is often omitted, this Roman numeral, because it becomes commonplace that this is the most widely used bonding scenario for silver. But because we don't get into that in this course, I require a Roman numeral for every transition metal, okay? Again, you get to higher level courses. There are common, what they call oxidation states, and you are required to know those. I don't do it that way. I just require a Roman numeral with every transition metal, okay? So then that way there's no question about how many electrons it's using to bond, okay? So again, all the elements that are in groups 3 through 12 on your periodic table must have a Roman numeral in its name. Okay, and that Roman numeral tells you how many electrons it's going to give up. So let's go back to titanium 4. Titanium 4 is this. So you don't need to look up on the periodic table other than its chemical symbol. Okay, oxide ends in IDE. That's my indication. It's just plain old oxygen from the front. It's atomic number 8. I look it up. What is the oxidation number on the top? It's -2. I cross and drop. Okay. Now we're going to take it to another level. What's the lowest combination of these two? We can reduce this one to this. Oh, excuse me. Because remember, this is like 2 to 4. That's the same thing as saying 1 to 2 when you have a proportion. So this will really impress me if you can take it to the lowest common ratio of these elements in a compound. Okay, let's do lots more. Okay, copper. So anytime you see a Roman numeral, you know where to look for the chemical symbol, copper 3 sulfate. Okay, so I'm going to incorporate a few things here. Copper is number 29 on your periodic table. It's in period 4, group number 11. This is its symbol. This tells me it's +3. Sulfate was from my last lesson. It's a polyatomic ion. I look it up on the back of my periodic table. It happens to be number 38. It is SO4, both capital letters here. It is a -2. Okay, the 2 crosses to here. The 3 can't go there without this coming into parentheses. Cross, drop. Let's rewrite that. Cu2 SO4 taken 3 times is how we say that. This 3 distributes to everything in the parentheses. So it really is saying like Cu2 S3 oxygen has 12. It's by multiplication because it's like saying I have 3 of these. So let's see how many elements, how many atoms are in 1 unit of copper 3 sulfate. 12, 3 is 15, 2 more is 17 atoms make up 1 unit of copper 3 sulfate. Exciting. Okay, let's do more. Okay. Let's see, which one should I do? Let's do lead. Now, lead is an interesting situation. Notice it is in group 4A. It's one of the ones with the +4, -4 over the top of it. Oh, excuse me. Okay. Now, this one, because it's to the left of the staircase, it's going to be the plus version of itself, because if it sat to the right of that staircase, it would be the anion, but it's to the left, so it's going to be the cation. So it can be this, okay? But notice it's an exception. So on the back of your periodic table, notice numbers 29 and 30. So we're getting into some exceptions here. There are two leads. There are lead 2, which is number 29, and lead also can be +4. There are other names for them as well. Lead 2 is also called plumbus, and this one's called plumic. Now, we don't use these naming systems here, but I do keep them on the back of the periodic table. So this one is lead 2, the stock naming system, and this is lead 4. Okay, these are the ones I want to use, but I do keep these here because we're going to do a food label project, and I want you to be able to recognize these other names that are often on your food labels as being these things here, okay? So let's do, so just so you know, on the back of your periodic tables, numbers 23 through 32, you're going to see some of them have other names to them. Because again, like I've told you, there's other naming systems out there that we don't use here. However, I want you to know how they relate to the stock system that we use. So I do keep them on the back of the table, okay? Just as a reference. Okay, so we're going to do one with lead. So let's do lead 4 hydroxide. Okay, lead is Pb. This tells me it's +4, not difficult. Hydroxide, if you remember correctly, it's one of 2 polyatomic ions that end in IDE. So it is not on the front of your periodic table. It is on the back, and it is OH, oxygen and hydrogen combined, and it carries a charge of -1. This does not need to travel. This 4 does, must put it in parentheses first. Okay, so let's count how many atoms. This distributes by multiplication to both places. So there's 8 there, 1 more is 9. There's 9 atoms in 1 unit of lead 4 hydroxide. Okay, now let's look the other way. Okay, what if I gave you the formula? Okay, now this is where it gets tricky. All right, so I recognize this is tin. Okay, but I've got to put a Roman numeral in there. And this is sulfate. So what I'm going to need to do now is look up the charge for sulfate on the back of my periodic table. Turns out sulfate has a charge of that. Now notice there's no subscripts here, right? Well, it must be because they crossed, dropped, and canceled and reduced. So this is why I say this is the last part of the ionic system, because it gets super tricky when you go from the formula to the name to try and figure out what Roman numeral goes there. Well, there would have been a 2 here and a 2 here. But we remember, we reduce these. So if this was a -2, this must have been a +2 because they crossed, dropped, and reduced. So this one, SnSO4 taken twice, is tin 2 sulfate, okay? So it gets a little tricky. Let's do one that's a little bit easier. Okay. Oh, we already did that. Let's do something different. Okay. Now that's copper. Cu is copper. Okay, going to need a Roman numeral. We know OH, you look it up on the back, it's hydroxide. Okay, now let's see. It's 2 probably came from up here. Well, a 1 there. Let's just double check. OH, we look it up. Sure enough, hydroxide has a charge of -1. So it was as easy as just pulling this number back up and that this is copper 2 hydroxide. Okay, I'm not going to work more in this video because it's getting quite long. Okay, so I'm going to post this one, and if necessary, I'll make another, and then we can work more. Okay, great.